formation, and then we found several of these. They're a little harder to find normally, but we have several examples of them. These are gastropods, a type of snail. So these are two characteristic fossils. So one of the ways that we know ages of rocks is that over a couple hundred years, people go into every one of these things, they lay out all of these fossils, they pile them up, and you'll see changes that are systematic in these fossils over time. This is called faunal succession, and it allows us to use fossils to tell the age of rocks. For example, if I find dinosaur bones in a rock, does that mean it's a modern rock? No. And that's one of the reasons, although I love Barney and Fred and Pebbles and Bam Bam, I have a problem with that show because people and dinosaurs are living at the same time. But that never happened. The last dinosaurs were 65 million years ago, plus a little more, right? We know this from faunal succession. These rocks, were they on land with the dinosaurs? Where were they? They were in the ocean. So these things were living in the ocean as seashells and snails. Maybe shallow water. And so this is not maybe the best example, but now we're finding these in the cliff. Did you get close enough before we leave here? So you can see those little things that are sticking out. Those are the big pectins. There's kind of little reefs of them in there. There's some of them cemented together, and they're sticking out. That's what you're seeing. So it's just loaded with these shallow marine fossils. This is Pliocene, and you have a time scale, and we could refer to it. I'm going to say, and we can look at it more later, but I'm going to save that for you and just let you know that these rocks are about 2 to 3 million years old. Is this a hard rock? No, it just crushes apart, and there's pore space in it. Most of the groundwater, most of the fresh water that you can drill down for, pump water out of the ground, most of the groundwater in San Diego County comes out of this formation, the San Diego Formation. So all the hydrologists and the drilling and stuff mainly goes into this formation. It's a beautiful exposure. If we look down the beach, you can see more of the San Diego Formation exposed in this sea cliff going in this direction. Now, if we look up here, we can see that there's kind of two. See, the upper part has all the pectins that are kind of sitting in it. Here are the pectins down here. What happens to those when you go that direction along the cliff? They go up a little bit, right? Yeah. And so you get a little, that maybe the rocks aren't quite level here. That's something we really want to keep our eye on. That's going to be an important thing here in a little bit. Okay, so this is one of the formations. Oh, and even at the highest tide in the storm, the ocean doesn't come up that high in the cliff. So what does that mean about geologic history here? Either the water is dropped or it's a relative motion, but we know that the ocean was higher at one time in order to deposit those marine rocks back there. Remember, I showed you ammonites in the Atacama Desert. I showed you Ordovician rocks at the top of Mount Everest. This is a teeny tiny example of that same thing. These are marine rocks that are now above sea level by one mechanism or another.
Above sea level, Mount Everest is a little more.